complete this experiment, we have to take some component, that is IC741, which is operational amplifier. One CRO is required to measure the output waveform. Okay, CRO probes you require, then registers of 10 kilo ohm, 5 kilo ohm, 4 kilo ohm, and 2 kilo ohm registers. These four registers you have to use to complete the circuit diagram. Then you have to use some multimeters and function generator to provide the input waveform. Like you have to provide some sine wave, square wave, or triangular wave. So with the help of this function generator, you can provide this input waveform. Okay. Then we require some breadboard and some connecting wires to complete this circuit diagram. Your connection, okay, positive and negative. So this positive, we can call this as a non-inverting input, okay, and negative we can call as inverting input. So here you will see positive connection is directly connected to the input supply, okay. So that means you are connecting non-inverting terminal to the input voltage. Then you have to connect your this negative terminal, okay, that is inverting terminal, to the input register that should be connected to the ground, and then you have to connect the feedback register to the output. Okay, just we have connected this output register. So here you are using this feedback register of 10 kilo ohm, input register of 1 kilo ohm. Okay, and from pin number 6 you will get the output. First we will scroll these components and select first this breadboard right here. Drag this breadboard and drop inside the working environment and change its position. Okay, you will find first option right here. Okay, this is the 741 operational amplifier. So use this operational amplifier and rotate its position right here. Okay, after this what you have to do, you have to select the function generator and power supply. Okay, so for function generator you have to search in the component list function generator. So you will find this function generator, select this function generator and place right here. Okay, so you will find this power supply right here. Select this oscilloscope. So here is your oscilloscope. Select two oscilloscope, one for the input and one for the output. Okay, so I am selecting two oscilloscope right here, and here you will find the first option for the register. Drag this, place this register across the pin number which you want to connect. So here we are going to connect input with this pin number 3. Okay, positive terminal, that is your non-inverting terminal, and second register you have to connect with the output. Okay, so this is your output, so this is connected to output. So what is the input for this positive terminal? Input should be connected as a sine wave, square wave, or triangular wave. Okay, so what you have to do first, you have to provide the this particular input, okay, to this non-inverting terminal. This is your function generator. So positive connection is to be connected to the positive and change its color to red. Second connection is negative, that should be connected to the negative, change its color to black. Okay, so uh, here you will find this positive connection. Okay, So this positive connection is to be connected with the positive. Okay, and change its color to red. And then negative terminal, you will see the circuit diagram. This negative terminal is connected with the 1 kilo ohm and in 10 kilo ohm resistor. So I am taking this value 20 kilo ohm and 10 kilo ohm value. Okay, so this 20 kilo ohm value is a resistor value is connected to the output and to the negative terminal, and from the negative terminal you have to connect it to the ground. Okay, so first connect it. So here we have two registers. Okay, this is your output pin, this is the register value that should be connected back to the which pin, that should be connected to the which pin quickly, this negative. Okay, then from this negative, yes, from this negative you have to connect this register to the ground. Okay, so where is your ground position? This negative is your ground. Okay, this is your negative. Okay, so here we have connected this output register, that is feedback register, back to the input, and then from here you have connected this register R1 to the ground negative. Okay, okay, good. So now you have connected the input. Now you have to connect the power supply, that should be connected to power positive. Okay, so this is your power positive. You have to give the negative supply. So how you will give negative supply? You have to connect this negative supply to the this particular power pin negative. Okay, so this is the negative connection, and where you have to connect the positive, that's why we can create this negative power right here, the output. And where is your output? Your output is at pin number, this is your output. Okay, so you have to connect it with the output right here. This is the negative connection, so you can connect negative connection right here. Change the color to black. Now circuit diagram is complete. Okay, you have to just give the values to the register, that is 20 kilo ohm for R1, and R1 that is 10 kilo ohm. Okay, and you can change this values right here. You can change the DC offset voltage. Okay, so you can change the frequency, you can change the function of this square wave, sine wave, triangular wave, whatever you want. Okay, and click on the start simulation. Okay, so here if you want to change its time per division, you can change it. It's your choice. I'm changing it to 99 millisecond. You can use the simulator. Right here you will see each and every component. Okay, just change this offset value. Stop this simulation, and here you will find the configuration of this function generator. I have used 1000 hertz, that is 1 kilohertz frequency, amplitude is 5 volt, and I have set this DC offset to 0. Okay, so change this DC offset to 0, then you start simulate this particular experiment. And here, when you increase this zoom level, you will find this is the 10-volt output. We will take this 10-volt as an input, and here you will find a 20-volt output. So this output is amplified right here. So that's, you can see with the help of this. And you can change this waveform also to sine wave. Okay, and you will find the simulator will give you output